Hello, I'm Alan Beesley. I'm the Commercial Director of Alps Ecoscience, who are a biological engineering company, and I'm also the Chairman of the Supergen Bioenergy Hub Industrial Advisory Board. So I am sorry I can't be here with you in person. However, given this subject matter, I think it's highly appropriate that you're listening to me in a digital format. So, my topic today is the digitalisation of the biomass industry, but specifically thinking about areas of my expertise, which is biofuels and biogases. So, um, I would characterise the biofuels industry as an analog industry in an increasingly digital world. The history of biomass is that it has been derived from primary agricultural processes, such as the production of maize for conversion into biogas as an energy crop, or from waste streams, and whether those are agricultural waste streams, food waste streams, or the processing of sewage, for example, which is a source of biomass, and other industrial waste processing processes. So these industries and these plants particularly tend to be geographically isolated in the agricultural sector. By definition, farms and production facilities tend to be away from cities, and so those facilities tend to be geographically limited. So there are limited economies of scale. At the other end, municipal sites, which may be on the edge of cities, which are processing huge volumes of food waste and or municipal waste, are at the other end of the spectrum. So what has tended to happen over time is, particularly in the biogas industry, is that farmers have a waste stream which then has given them an opportunity to begin producing some energy, almost as a marginal addition to their core business. And in many cases, that was enacted by government subsidies maybe 20, 25 years ago. Anyway, so as the industry has been driven by the pursuit for low carbon, so essentially the biogas industry is a direct replacement for fossil gas. So there is a huge opportunity and a big momentum, which has initially been driven by government legislation and now driven by a general consensus that the planet is warming and there are mitigations that are required to slow the rate. So fundamentally, we are talking about an industry that's evolved over time, and one that is traditionally come about through family-owned businesses, through the use of management of an incremental waste stream. The industry tends to be dominated by individual experiences, and so by its nature, it is not a vertically integrated, data-driven industry. Now, by contrast, the major competitor, which is the fossil fuels industry, is a vertically integrated industry. It is a chemical process as opposed to predominantly a biological process. So that in itself means that it is more predictable and the outcome is more consistent. And perhaps, arguably, it is therefore easier to consolidate production into very large facilities with economies of scale. However, that industry, which is 100, 150 years old, has had many, many years to begin to embrace monitoring, the use of sensors, and the use of vertical integration. So the main driver in that was in the 1970s, where the oil crisis drove an efficiency focus for the industry, and so that when a well was opened, the industry wanted to be able to measure production and align that production to the final market price, and so you had small incremental gains across the industry. So there is a model there. If we look across from the biofuel and the biomass industries to fossil fuels, there is much that can be learned in the use of data, in the use of creating a vertically integrated system where you understand the input costs and you understand the market drivers. So what I present to you today is an opportunity to think about how an analog industry that is predominantly reliant on individual plant managers, their experience and their gut feel, which tends to mean that there is huge variance in production just based on training capability site to site. So that's your first challenge. The second is to do with data. So the industry to date, I would say university runs on spreadsheets. Those spreadsheets are produced through a combination of machine-read data. There are control systems called SCADA, but there's still a lot of manual readings from analog systems, analog counters, and observational data. And then finally, there is a requirement for laboratory results. Those tend to come retrospectively because the lead time can be a week or two from the point they were drawn. So the picture is there of multiple data sources that are unstructured, but if they can be interrelated, time-stamped, then huge amounts of information can be gleaned on the process. And being a biological process, to date, I would say that the industry has to be conservative in the way that it predicts and also in terms of it feeds. And so there is the opportunity to, one, improve prediction based on being able to create an accurate picture of all of the input and output data and join those together. And secondly is, once you have a picture, then to use that information to begin to look at opportunities for efficiencies, opportunities to reduce waste, opportunities to reduce risk, and also opportunities to valorize. So let's say biogas, for example, that can be directly injected to the grid, but it also can be converted to electricity, it can be compressed, and it can be liquefied. It could also be stored for 24 hours if it is opportune to do that, if a price is rising or falling. So the picture today is an industry that needs to compete with fossil fuels, needs to reduce its operating costs because the environmental imperative isn't enough. It needs to be economically compelling as well as environmentally compelling. So my challenge to you today is think about how we start to develop a carbon negative, competitive biofuel market and the role that digitalisation can play in that. So I look forward to hearing the results of today over the coming weeks, but enjoy the session, and sorry I can't be with you.